So today we look at exponential versus linear. Now linear functions are what you're most used to, y equals mx plus b. Exponential functions is the new function that we introduced last class. So comparing the two is actually going to help you learn them better, both of them better. So by the end of this class, you'll know the differences between a linear and an exponential function, and you'll be able to write an exponential function given a linear function, and vice versa, all right? So here are the two functions. One, the exponential, the new one, y equals a times b to the x power. And then linear function, y equals mx plus b, the one you're more used to. Similarities and differences. Notice that they both still have a y and an x. The reason why they have a y and an x is because we're still graphing these. It's still all about an x value with a y value, a two-dimensional space where you can plot values, plot points, okay? Other similarities are related to the AB and the MB. Now, B and B in both equations does not mean the same, and we'll talk about that. But mostly what we have to realize is that they indicate a y-intercept, an initial value. So both of them have that power. The B, all right, in the linear function, here's your y, whoops, I can't write yet. This is your y-intercept, but it's the A in the exponential, and we'll talk about that a lot today. Also, both indicate whether the function increases or decreases. So when it was linear, if it was positive slope, it increases. If it was negative slope, it's going down. With an exponential, if the b value is bigger than 1, it's going to get bigger because we multiply. And when you multiply by a number bigger than 1, things grow. But if you multiply by a number that is smaller than 1, things decrease. Now that doesn't have to be a negative. Listen to what I said, smaller than 1. Multiplying by a half cuts it in half, right? Multiplying by a quarter cuts it in 4s. So it's just multiplying it by a number between 0 and 1. As for the differences, how are they different? A linear function adds a constant amount, all right? So you have to make sure you're using addition and not multiplication. Secondly, the difference would be just what I said. An exponential function multiplies by the same amount. So linear add, exponential multiply. If you can remember these things, it will certainly help you in understanding what's going on. All right? So any questions, type them in the chat. I'll give you the chance to write all that down. That is a lot. So now let's get into this with a couple examples. And let me get my pen feature moving here. So linear functions are repeated addition and exponential functions are repeated multiplication, where one's the slope and the other is just simply a base. Looking at these two tables, one's linear, one's exponential. Which is which? Let's see if we can figure this out. Well, the x values are going to go by 1s today, so we're not going to be tricky here. In 8th grade, they may have changed by 2s or 3s or moved around. In 9th grade, we're just going to keep it simple because we're trying to talk about something else. So you didn't even have to write that. I just wanted to show you sometimes that doesn't always go by 1s. Now the outputs, the y values, here's where we really got to look. As we do these little kind of arrows here, we got to look at how it's changing. And last year in 8th grade, I know you did this a lot, it was changing by how much you were adding by. But here, the difference between 5 and 10 is 5, and then it goes up from 10 to 20, so that's a difference of 10, and then it goes up 20, and then it goes up 40. So it's not adding the same amount, and that has to be repeated. It has to be the same, and it's not here. So what else is happening? This is being multiplied by 2, okay? So this is an exponential function. Because it's being multiplied. All right. On the other side, we've got numbers for outputs. And again, let's kind of look at how these are changing. 8 to 11, 3, 11 to 14, 3, 14 to 17, 3, 17 to 20. It's just added 3 every time. So adding 3 every time makes this a linear function because b/c, shorten it up a little bit, it's adding 3 every time. Boom. All right. Take a minute, equation for both. Okay. So looking at these two tables, we know that 1 is being multiplied by 2, and the other is adding 3. Now, we said that this one over here is exponential. So y equals a times b, which can be put in parentheses, to the x power, where this one's linear. Y equals mx plus b. Okay? So let's start with the new one. Let's see if we can pull off the a value. Now, the a value is always where it's a 0, right? So there's a, the y-intercept. So that's going to be 5. We don't write the 0, we look at the output. So it crosses at 5, it multiplies it by 2, and we raise it to the x power. That's it. That's all she wrote. As for the other one, we want to find the initial value. Again, identify where there's a 0 in the table. There's the 0, 8. This is the b value. That's how they're different. This means y-intercept, but it uses a different letter. The slope was how much it was increasing by, so 3, so 3x, and then add your 8. Okay? So that's just to write an equation for both the linear and the exponential from just 2 points. That's it. That's all I give you. 2 points. Now, one of those points is going to have to be the y-intercept. So let's take a look. 0, 12, 1, 3. So we used the 2 points for the first one to find the linear equation. We subtracted the y values, subtracted the x values, got -9, and then plugged it all in to our equation. Now for the next one, we can do the same thing, but in order to find the b value, we don't do the slope formula, we do this new one where we divide. Now the reason why we divide is because it undoes multiplication. So if we've got two values and we know that they were multiplied, we can undo that to see what they were multiplied by. So y2, same thing right here, is 3, y1, 12. So the bigger number is in the bottom, smaller number is in the top. But just because of the order that it came in. This is actually the second value, the 3, and the 12 was the first. So 3 out of 12, let's change that to 1 out of 4. I'll ask about the start. Now again, the start, the y-intercept for this is the a, but it doesn't matter. It's still 12 because we're using those 2 points, okay? So put it all together, y equals 12 goes first, parenthesis for the half, raise it up always to the x power. So you got a y and an x. Now let's come over to the graph, and I'm going to plot a couple things first, and then we'll bring out the calculator. So we know that the y-intercept is 0, 12. So I'm going to go up here, plot my point. So there's 1 point. And then the other point is going to be 1, 3. So 1 to the right, up 3. Now, the two lines, the two equations for that matter, are going to go through those points. Now, on the calculator, we're going to need to change the window so that we go from -2 to 2 and from -5 all the way up to 15. And these compound inequalities told me that. All right, they told me the window that we want to use. So let me show you what that looks like. So here's your TI-84 Texas Instrument Calculator. If you would like a discussion on how to use maybe Desmos or the GeoAlgebra calculator afterwards, please let me know. But I'll do this for those that did borrow a calculator in the beginning of the year or did went out and purchased one. So go ahead and go to y equals, type in the two equations that we came up with. Let's do the linear one first. It's got to use the negative key, the one under the 3. Can't use subtraction here. 9, then the variable key, and then the plus 12, the y-intercept. Go ahead, arrow down, enter the next one, and you enter it exactly as you see it. So 12, even include the parentheses. For a fraction, simply do 1 divided by 4, okay? Close the parenthesis. How do you raise it to an exponent? Raise it on up to the x power. All right. Now, if I went too fast for you there, ask a question, I'll do it again, or I'll post the video and just fast forward to this part and you can see how I did this if you need to in your homework. Now, as for the window, calculators are going to start in a standard 10 by 10 by 10, which means 10 this way, I can't write 10 this way, 10 left, 10 right, 10 up, 10 down. But we needed to change that. And so it wanted to go from -3 to +3 in terms of the x. So I'm shrinking the left and right distance. And then it wanted to go from -5, so below 0, down from 0, 5, and then up to only 15, so 1, 5. So I'll show you in a second here on the large screen what we just did. And I press graph, and voila. You can see that there is only 3 to the left and 3 to the right, 5 down and 5 above. And there you have it. One line that is straight, one line that is curved. There is your linear versus exponential. Now, I put those points on the graph prior to even doing that because I knew if we use those 2 points, the linear, was going to go through those 2 points as a straight line, decreasing in value, and the exponential is going to go through it in a curved fashion. And as it curves, remember, it does not go below the x-axis. So there is a good comparison of the 2 different graphs. Definitely an exponential. So we tell you from the beginning, it's exponential, and we want to try to figure out the average rate of change. So this is a big thing that we do a lot of. Haven't done it as much this year, but it's a really important skill. So average rate of change, again, is the y2 minus y1, x2 minus x1 formula. So we want to go from 0 to 1. So we're going to look at this block of numbers right here. Here's your x's, here's your y's, and you're simply looking at the first point and the second point. They look a little different when they're in a table, but it's still 2 x values, it's still 2 y values. So subtract the y values, 8 minus 4, subtract the x values, 1 minus 0. 8 minus 4 is 4, 1 minus 0 is 1, so yes, it is just 4. So average rate of change for that one is simply 4. Take a look at the next one. I'm not going to write the formula down. I do want to change my marker real quick. So we're going to look at this block of numbers here because we're going to go from 1 to 2. So that's going to be 16 minus 8 and 2 minus 1. So 16 minus 8 is 8, 2 minus 1 is 1, so 8 over 1, yeah, we're talking about 8. One more time, and hopefully we'll kind of see the pattern here. And if we did the average rate of change from 2 to 3, we're talking about these 4 numbers. And again, to find the average rate of change, we're simply going to subtract. And 3 minus 2, again, it's just a difference of 1. 32 minus 16, though, is a little bit bigger, 16. So this next part asks you to go and figure out what's happened. It's gone from 4 to 8 to 16. 4 times 2 is 8. 8 times 2 is 16. We should have known it the whole time. We were multiplying by 2. So and we call this the rate of change, the ROC, is doubling each time. And I don't get all fancy or technical with my definitions. I'm not that kind. And the linear function is y equals 20x plus 5. The other is simply 5 times 2 to the x power. So they both have y-intercepts at 5. So we're going to put a point there, point there. It's not going to change. But what is going to change is the window. We're going to go from 3 to 6. For x values, we're going to go from 30 to 150. Okay? So 1 is the linear, and that's simply 20x plus 5. And the other one was the exponential, 5 parenthesis 2 raised up to the x power. All right? Change the window, and we want to go from and 3, that's already there. And then for the y's, we want to go from 0 to 30. And press graph. And what you look like is you have a linear and an exponential. Okay. exponential is going to beat